this equation. You're trying to get x by itself. Think about what we just did in the homework problems. What would you do if we're going to approach this by completing the square? Natalie? Good. So we want to do the b over 2 squared, but we can't do that if a is something other than 1 and we don't know what a is here. So what would you guys want to do prior to doing that? Divide by a. So we can go through and divide everything by a first. And so if we're going to do what Natalie said, and we're going to take the middle term now, divide it by 2, and square it, it is what we want in this constant spot right here. We don't want this c over a. We don't know what this is. We don't know that for sure it's a perfect square. So I'm going to move that one over too before I do what she said. Is that okay with everybody? So I'm going to subtract c over a. I'm going to leave a little spot for what I know I want to add to each side. So what do we get if we take our middle coefficient, which in our case is b over a, we divide it by 2 and we square it. So b over a, when we divide that by 2, what's going to happen to it? It's going to be b over 2a. It's like multiplying it by 1/2, right? So it'll be b over 2a, and then we're going to take that and we're going to square it. So we're going to be adding b squared over 4a squared. Is that okay with everybody? These are the same steps you go through, just kind of in super generic terms, but that's what makes math hard sometimes, right? This abstract of trying to generalize everything. So I can add that to the left side if I also add it to the right side. So if this value, even though it looks super weird and says b squared over 4a squared, completed the square on the left side, I should be able to then factor this to be a perfect square. Okay? So this factor would have what as the first term? X. And then what as the second term? Good. The stuff that was squared to make this. And should it be plus or minus between them? Plus. Okay. And then over here, I'm going to try and combine those fractions into one fraction, which means they would need a common denominator. Right now, they both have one factor of a in common, but this one would need another factor of a and a factor of 4 in order to combine them together. So when I do that, they'll both have a denominator of 4a squared. And then this numerator will be a negative 4ac and plus b squared. Math is pretty amazing. It's okay if you can't hide your excitement. So I know, it's pretty cool. So what are we going to do next? We're going to square root both sides, okay? So when we square root both sides, this side is just going to be x plus b over 2a. This side is going to be positive or negative. Okay? What is the square root of the denominator? 2a. The numerator I can't square root. You can't do it piece by piece because there's things being added together. So we got to keep all that under the radical, but I'm going to reorder it just because this is normally how you guys see it. Instead of writing it as negative 4ac plus b squared, I'm going to write it as b squared plus negative 4ac, or b squared minus 4ac. Okay. And so what's our last step to get x alone? Subtract this, right? And then I get that x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And so since they have a common denominator, I can write them as one fraction, okay? So x can be equal to this. So every time that we're walking through the process of completing the square, we are doing this. with the A, B, and C values. Okay, what do we call this? The quadratic formula. So did somebody just pull it out of thin air? No. We had this way that we could solve everything, but if we're going through this process of steps every time, it got annoying, right? When things were fractions and you had to divide them by 2 and square them and stuff like this. So they're saying, if I'm doing the same thing every time, is there a way for me to just generalize and say, here's what I'm doing? And this is it. Okay, so they came up with a way to generalize it, and that's your quadratic formula. So this is why, you know how we talked about, like, you might choose factoring to solve. You might choose quadratic formula. You might choose completing the square, but it kind of ends up being pushed away by people as kind of their not most favorite method. That's because when you're doing the quadratic formula, you're doing all the steps of completing the square in one step if you have the formula memorized. So of course people end up choosing it over that. It's the whole reason it was developed, right? Is to save you all the time of taking all those steps one by one and instead put it into kind of like one step. All right? So the goal today is just to make sure we can use the quadratic formula. It should be super familiar because you guys have done it in Algebra 1. So for example here, if we're going to use the quadratic formula to solve this, you first need to have everything on the same side of the equation set equal to 0, or you do not yet have your A, B, and C. Okay? So that's probably kind of the biggest, like people look at this and they're like, oh, A is 5, B is -2, and C is +2. No, okay? Because you didn't have it set up in the standard form where you had ax squared plus bx plus c all on the same side. So your A is 5, your B is -2, and your C is -2. So when you look at the formula we just looked at, it's negative B plus or minus, and then we have B squared minus 4 times A times C all over 2 times A. So most common errors with the quadratic formula, what do you guys think? What do people mess up when they're using it? Huh? Yeah, negative signs tend to be the most because you're like, oh, negative B. Sometimes if B is already negative, you don't put the negative there, then you don't get a positive here. Okay? Or not using the sign with C or the sign with A that go with it, or not squaring this properly and then leaving a negative there. Those are usually the things that go wrong for people. Sometimes people don't have it memorized right. Okay? But that's not where I see most of the errors, especially in here. Most of the errors are just doing your arithmetic right and making sure you're being thorough when you're doing it. Okay? So this is a +2. This is a +10. So let's look at what we have inside this radical. -2 squared is 4. Okay? And then 4 times 5 is 20 times 2 is 40. Right? Is this going to be 4 plus 40 or 4 minus 40? Plus. There's a negative here and a negative here, so when these three things are multiplied together, they'll end up being positive. Okay? So underneath my radical, I have a 44. Then the question becomes, can we simplify 44? Marcus?
Just 2 and 2.
Okay. So 2 rad 11, right? Yeah. Okay. So we are going to have x equals 2 plus or minus 2 rad 11 all over 10. So can this be simplified? Can. Remember that 10 is a denominator for both of those 2's. So essentially when we're looking to cancel factors, I know you won't normally write it this way, but you're normally looking up here and saying, do these two things have one factor in common? Okay, which they do in this case, like they have 2 in common, right? And then you're asking yourself, is there also that factor or part of that factor in the denominator? And so we're basically thinking of 10 as 2 times 5, and those 2's are allowed to cancel. But my main point in doing it, I get you're not going to do it like this every time, but my point in showing you this is to understand that a factor of 2 canceled this factor of 2, and the 2 also canceled this factor of 2, because this is a denominator for both of those terms separately. A lot of you guys say, oh, 2 goes into 10 5 times. You then don't make this a 1. You just leave it complete. All of a sudden it's gone. Okay? And then you make this a 5 and say that this 2 is still 2. But remember, this 10 is a denominator for each of these. So you have to, really you can only factor these three numbers here if they all have a common factor and they're all getting that factor canceled out of them. Yes. Yes. Okay. That it can be canceled. Yeah. So we would have these solutions for x. This is two solutions. These are times when you would see it not cross at a really nice place on the x-axis, right? Because like, what's rad 11? It's a never-ending, non-repeating decimal. 1 plus that divided by 5 is where this is crossing the x-axis, and 1 minus that divided by 5. Okay, so we write it in this form. Okay? All right. Yes? Oh, yeah. So there's a 1 here, yes. Okay. But that's 1 times rad 11, so it's like writing 1x. Like, it's correct if you write it as 1x, but it's the same thing as you write it as x, because 1 times that doesn't change it. Okay? Is that all right with everybody?